My name is Prashant. I'm a Senior Cybersecurity Advisor for Enrich Pipelines. I've been in this industry for 17 years. I'm one of the organizers of the BSides Edmonton conference. So welcome everybody to this conference. It's been great to see everybody, the enthusiasm, the community spirit. Michael Spaulding's keynote was bang on. It's about community. 2017, 10 people to 600 people, almost that we are finding overcapacity on these rooms. I'm joined by my colleague Rajat Kundu. He also works for Enrich. He'll give his own introduction, but purpose of our talk, and we'll try to be very honest on our time. It's a big talk. It almost goes to an hour. We have given it on a couple of forums now, CS4CA Calgary. We also gave it to ConocoPhillips and to their CISO suite on OT cyber attack simulation on a chemical plant. Enrich doesn't deal with chemical plants, so full disclosure, this conversation, this content is purely our own research. It's research of both of us in terms of how we can look at OT cybersecurity. But in general, it's just showing you what's the art of the possible in operational technology. So I'm sure folks know, at least they have heard of OT or industrial control systems. If not, you can take me on the side and I can give you a bit of a primer. I'm not an expert in this field. We all learn as we go. But with that said, we'll be honest to our time, and we have a couple of simulations to show you. I'll hand it over to Rajatji for his introduction and to proceed. Right.
So I'm Rajat Kundu. I'm also working with Enrich with Prashant, contracted through Dexon. So my role is, OT networking and cybersecurity. So with our relationship, he is actually my client who I have to actually satisfy. He's our cybersecurity advisor. So that's one of the key things, is that when we are dealing with OT and IT stuff, and especially cybersecurity, it's a collaborative effort. Not one single person and not one single team can do it. It's actually, everybody has to do it together. Professionally, I'm a professional engineer. I'm a PEGA member. I'm a project management professional, as well as I'm a CISSP. So I'm having 3 different hats, on my head: engineering, cybersecurity, and project manager. And to be honest, in today's scenario, that's what actually works well. So starting with our presentation, we have, our presentation is about introduction to OT cyber attack. So first of all, what we are going to know about is that what is exactly an OT systems and what is an OT cyber attack. We will be talking about some of the external attack services. We will be looking at a little bit of Shodan, what Shodan is, and how we can use Google Dark using generative AI. We will be also studying one particular industrial protocol. We all know about the common business protocol, HTTP, HTTPS, and so on and so forth, but we are not much familiar with the industrial protocols. So I'm going to take a little bit of deep dive into one of them. And then after that, we will be going into a real chemical plant simulation, which is like a graphical realism framework, which is designed by the 45. We will be presenting you that graphical realism. And we will be discussing a little bit about the OT systems, how the architecture of the layout works. We will do a demo where we will be doing an R-spoofing of a human machine interface. And then we will be injecting some malicious command through the Modbus that we will see before that. And given the time, if there enough time is there, we would be actually upload a malicious program into one of the PLCs, simulation PLCs. And if you are lucky, with enough time, we'll see the chemical plant blowing apart. So what is an OT cyber attack? So the OT system is basically, it's a physical system. It's very physical in nature. It's consisting of walls, measurements, motors, and so on and so forth. So OT cyber attack actually can disrupt a very, very physical process. And it can create a real world chaos. Some of you might have seen some movies, 8 Mile Island, probably, or Deepwater Horizon. So some of those actually bigger incident, cyber attack can actually create one of those incidents. It's a practical possibility. So OT systems are the heart of critical infrastructure. So these infrastructure nowadays are increasingly connecting to IT systems. And also because many of the systems are actually complicated, they are supported by remote engineers. So they're also getting more exposed to remote access platforms, and they're getting more and more vulnerable and exposed to sophisticated cyber threat. So what we are going to do is that in our workshop, we will mimic a real life scenario. The aim of this mimicking is that we will be trying to see what are the different vulnerabilities in our OT systems, how we can detect, a threat, and how we can respond and recover from one of those cyber intrusions. So this is one of our...
Just on to that, before we go into the Purdue model, which Rajat will speak about, I just want to give you a feeler of what operational technology systems are. For those who are in this field, we live in the world of oil and gas and energy, right? Alberta, the province of oil and gas, that basically puts money into our pockets through various means. That's the commodity which makes money for the whole province. I work for Enbridge, pipeline industry. So just to give you an anecdote of what actually OT systems look like. So I have this prop. This prop actually looks like a pipeline. A pipeline has a flow of gas. It could be a flow of oil. If you ever go to any of the field sites, if you drive by through farm fields, you will see that there is actually a valve. This is a very crude representation of a valve with the pressure on a pipeline. You might see some manual valves people actually go in and put it in and out. If you ever go through past one, don't ignore it. Go check out that and just see how those farms look like, or how those pump stations or whatever the case maybe looks like. So this is one example of a pipe flowing gas which could have a pressure gauge on it, and it could have a manual valve. You and I, we have plumbing systems in our house, right? When it leaks, what do? We turn off the tap. We turn off the valves behind, the final valve, which actually puts water into our houses. Why? Because there is a leak. Very similar systems, very similar principles, at least on the pipeline infrastructure. They could be refineries, there could be other infrastructure as well in the OT space. Another example I'll give you is tank terminals. If you ever go past the Anthony Hande, those who are Edmontonians or local Edmontons, there is a full spiel around the Anthony Hande, what's called the pipeline alley, big tank terminals. Enbridge owns some. Suncor has a refinery out there. Esso has a refinery out there. These tank terminals look pretty naive. They just store oil in there. But imagine for a moment, which is something we're going to show on the chemical plant, if you can put enough oil, which actually pumps out oil out of the flow of the terminal, of the tank, and there are various possibilities to do that. Very naive, the oil will flow out, there'll be a leak around it, and the leak could have, some impact. It could have environmental impact. We live in the world where environment is very, very important. And you can have consequences deep down in your OT environments. Look at electricity coming into our environment, right? Middle of the winter, minus 35 degrees. Electricity goes out, supply chain disbalances between Alberta around generating plants. We can't buy electricity from our neighbors. The grid disbalances. Maybe you are blacked out for 6 hours, 7 hours, 10 hours, 12 hours. I don't know how many of you I'm sure you all are probably older. To 2003, 2002, the blackout, the Eastern blackout, which happened, led to a lot of issues around. And I still remember pictures of people sitting on traffic lights thinking, what else we're going to do? We are so dependent on these systems, we don't realize them. Power, gas, water, electricity, you name it. These are systems which run society. So it's important when we look at IT security or cybersecurity that this aspect of cybersecurity around operational systems plays a very important and very big role. I have been a physics student in my life, and marrying physics with cyber is so beautiful because ultimately you figure out how physical principles can be compromised by cyber means. And there are various ways you could do that over the industry. I've been in this field for 6 years now. So this is another example of a tank terminal. I'll give you another one just to give you an idea of what these systems look like. What you see here is a nano-precise IoT sensor. It's a vibration monitoring sensor which actually sits on top of the pipeline. When the pipeline vibrates, and it can vibrate for various reasons, this actually creates a wireless sensor signal which goes down out into our SCADA systems, and there's a whole 9 yards how you control these systems. Because they're so critical, even vibration on them, volume, temperature, vibration, they can become an issue if they're not monitored properly. This is a real-life example of an IoT sensor, which can be put. It's a magnetic sensor. It just plugs in and does a wireless comms back into the gateway, blah, blah, blah. So these are just examples to show you how IoT systems look like, how OT systems look like. In your own houses, when you look at thermostats, that's a very simple human-machine interface, which you're going to talk about, which looks at your thermostat. So just to give you an idea, to get you in that frame of mind of what we're talking about, and then how these can be compromised for the detriment of human safety. Why Rajat ji and I have put this PPE hat? Ultimately, the aim and the subject of our discussion today is making sure as we are going into these fields, we look about information security on the IT side, but there's a human element to it, and that's human lives are at stake. PPE is always important. If you are in this field, if you ever go into technical sites, make sure you have them. It's not about just being an oil and gas. It's about being a construction worker. It's about being in a road, construction going on, whatever the case may be. Because what's happening now, cyber is not about only hacking emails or taking your confidential information out and being a reputational impact to you. Cyber is now going into the world of OT and industrial control systems where it could kill people. Somebody very interestingly told me one day, he said, look, a doctor, if he messes up, can probably kill one patient. An engineer, if he messes up, can kill thousands. Let that sink in for a moment. The rules of information security or operational security are written in blood. That's what they call it in the world of engineering. Because people have gone through these things, they're so sensitive and so critical, you don't want a human life to be lost because there was a misconfiguration on a system. And so keep that in mind. We talked, Michael talked about in the morning, confidentiality, integrity, availability. The other aspect of OT industrial control systems come around reliability and safety of operations. Again, we live in a province called Alberta, oil and gas, any energy infrastructure is important. These things play a role in the society. Knowing the reliability of operations, knowing that safety is at stake for those technicians is very important. So just wanted to give you that context. Over to you, Rajatji.
Right. So the next slide is about an IT and OT podium model, which actually shows how the physical systems or the control system or the OT system is laid out. And I have a little prop here, which I prepared just to show how to correlate them together with the screen. So what we have is the lowest level, which is the sensors, and we have a little potentiometer here. So analog and digital sensors, which actually some of those props, Prashant has shown. The valves, it's an actuator which can be commanded by this little board, which is on the layer 0.
So they're always in this level. Sorry, right. If you can go ahead.
And
all these devices.
We have the upper level, which is the PLC, which is a programmable logic controller, which sends actually the signal to these devices, which close and open, the valves and motors and stuff like that. And then we have a level 2, which is an HMI. So this is how a person gets a visibility of these things, what's going on here. Because these things are huge. You cannot just see them with your own eyes, in one shot. You need to have those graphics somewhere so that you can get an overall picture, which is where it's shown up. This is one of the vulnerable parts. If you get access to this guy, if you have a current, right credentials, you can actually mess up with everything down here. You can create an oil spill. You can actually, make a transformer blow up. You can do lots of things. And then we have the next layer, which is the layer 3. Now, this is where the data gets collected. It's a historian. It's a computer which collects all the data which is flowing up from down all the way up, and it's storing all the data. This is what goes to the business side of the things, where somebody else, somewhere else, is actually monitoring those data and making critical decisions, the business decisions. So we have a point in the Purdue model where you see that we have a firewall which is segregating the IT and OT network. Everything here is very physical. It is safety related. Availability is very important here. And then we have the data, which is the cream of the thing where all the data moves, which is the interfacing between IT and OT.
So just to give a quick update on that model, it is just a reference model. It's not how it looks like in the field, okay? This is just a reference model to show you how these are zoned, how those security enclaves or levels are created for those systems, to give you a kind of a understanding of how, when we look at cyber, when we look at OT environments, how that does play a role. You could literally have an IT system sitting next to an OT system, and you would say, hey, it doesn't fit my Purdue model thought process, so it is wrong. That's not how it works. When you see in the field, this is just to give you an idea. But that's a beautiful way of showing how you can model OT systems, which are literally these systems, and they can be detrimental to human safety, as we talked about, including operations and the reliability of that.
So the next one is we will just discussing a little bit about the common attack surfaces. So one of the most vulnerable thing on the Purdue model or on an OT system is that its connectivity with the IT or the corporate network. The second thing is that there are those devices, IoT devices or the specialized PLC devices, which needs better support. There are 100 different types of vendors, and it's not possible for a customer to know all of them by heart. So they are depending upon remote support for those devices. In addition to that, there are those HMIs and SCADA dashboards which could be internet exposed, There are also many different third-party vendor support as well. We have wireless communications with the OT systems and the cloud service integration, like API data. We have historians, which connects to connects to internet, and probably those data that's getting stored in the cloud as well. Plus, there are many physical things like the USB stick and control room cabinets, which are very, very physical. So physical access to those equipments are also very important. You might have seen in some of the movies, some big star gets into physical access to some critical infrastructure, do the biometric scanning and do things. So that is the physical aspect part of it. Plus, there are many sensors. IIoT sensors are there. Temperature sensor, you can manipulate the temperature values and you can give a totally different kind of scenario. So those are the vulnerable points or the common external attack surfaces that is possible. So the other thing we will be discussing is that now what I'm talking about is basically the OT system, which is a highly specialized field. But again, to hack into the system, you may not need to be an engineer. You may not need to have an in-depth knowledge of those systems. It is still possible to hack. So one of the search engine that I would show you is the Shodan. Now what it does is that it indexes all the devices and services. It scans IP ranges and banners, and it has the ability of finding any IT/OT devices, router and switches, database and servers, which are actually actively connected to internet. Our aim is to protect the systems so that they are not directly exposed, but there are many in the world as we speak, which are actually connected to internet without any protection. So we will just take a look into a few of them.
So while he does it, how many know what Shodan is? Quite a few. So that's very good. So Shodan is basically a search engine you can use for looking at vulnerabilities on the internet, connected networks, and stuff, right? So you can create a free version, a free account, or you can create a subscription one. What Rajat is going to show is basically we don't know sometimes Shodan queries because we are human beings. You can't get enough information about cybersecurity of everything. Can I use AI to create me Shodan queries to look for OT systems which are vulnerable on the internet and then use them either targeted to my company or whichever subject scoped company we are looking for, or in general? So over to you, Rajat.
Right. So let me just open up my internet screen here, and I'm gonna go to Shodan. I will go to ChatGPT. And I will be running a query, which is very, very simple. Generate a Google Doc. Is my screen available there?
So while he does that, some of you who may have been speakers and stuff would have gotten these decks today, the backdoors and breaches. We had a limited number, and we got it from Black Hills InfoSec. But anyway, there is a core cloud security deck. There is a core deck for IR, and there is one especially for ICS and OT. If you are interested ever in doing incident response in the ICS OT world, you can actually gamify incident response, play within your own teams in this space. I haven't played with it. It is literally in my hand. It is brand new. I'll give these two away to those who ask questions, and hopefully we have time for questions in the end. So we'll see how that goes. We'll see how much, is the enthusiasm of this startup.
Right. So for example, I'm gonna use a Google Doc query to find external OT assets with Modbus exposed as a session and educator. Now, if I run it, it is going to give me a result, which is going to give me some of the Google Doc query.
Can you expand it, sir?
So it is going to give me some results, and if I copy it and I put it on just Google search engine. So I don't know anything about OT systems, the PLCs or Azure or anything like that. But once I make a query, it gives me all the resources that I need to make a study and understand what it is. One of the most common protocol is Modbus. It just tells me this, it gives me a Google query on it, and I can just research and I can find everything about that particular technology. So this is, one of the way, even if somebody is like, non a technical, OT person can learn and find about things. And then we have this, Shodan. And if I just go to and just say, I look here on the Google Doc, through the Google Doc and Google search engines, it gives me a result of Modbus and Siemens, some of the name of the company. I go to Shodan and just say Siemens HMI, and it just tells me some of the exposed system which we have. I can just keep on trying. Let's say I just go and try this one, see if I can, if this one pops up something, and let's see what it pops up. Oh, it does open something, Now it is telling me an exposed system, and I did nothing. I just, it was a normal guy playing around with, Chat GPT, run a Google Doc, and put it on Showdown, and it just opened me an information about an.
By the way, there's no MFA here, okay? You already saw this. By the way, this could be a honeypot, it could be a real HMI system. But this is what it is. This is how exposed the whole internet is. Not that your own organization could be. You can tailor those queries towards that. But the idea of showing you this example was the fact that the cost of going into OT cybersecurity from a bad man's perspective has reduced. You don't need to know OT queries, or you don't need to know much about. You can use ChatGPT, get a query, run it on your organization or on the internet, and get a default page of an HMI system. By the way, Siemens S7 PLC, if anybody's ever interested in Stuxnet, you guys heard of Stuxnet? 2009, the biggest cyber warfare weapon which was ever created. To this date, it actually holds that title to my understanding. S7 was the PLC which was compromised by the so-called folks who created Stuxnet. I'm not going to go into details of that, all right? But it went into the Iranian centrifuges. It checked out at the back end. It actually exploited 2 zero-day vulnerabilities in S7, and it led to the centrifuges going fast. But on the HMI, they were literally saying, "Oh, we are in the bounds of it, and we should be okay." And the more you get away through a tolerance level of a particular machine, it basically comes down, and that's what happened in the Iranian centrifuge attack with the Stuxnet. So this S7 PLC, by the way, was the culprit in that. It still is one of the main ones which is used in the OT world right now for testing and cybersecurity testing purposes. But this is just an example of a web version of an HMI which sits on that PLC or similar products of Siemens.
And one of the interesting thing is, most of the people, including me, once upon a time, in OT systems, we are lazy. Lazy in the sense, confidential is not that very important for us. Safety and reliability is. Safety, reliability, and availability is what we die for. We are not very good with confidentiality. So most of the, you see here is a username and password. So most of the HMIs and PLC email today, you would find many of them are using the default password and credential. Go into internet, you can find the default password and username. You can actually directly get into those HMIs and manipulate things. Things are improving as people like me are getting associated more and more with cybersecurity experts. We are improving day by day, but there are many cases where we still see these kind of things.
Just to add on to that just a little bit for a couple of seconds. So cybersecurity in the OT space doesn't have to be about pilfering information out of the OT environment. It is about manipulating physical aspects of the operations. Okay? You have a pipeline, running a pipe at a certain pressure P1. If you go from a P1 to a P1 plus whatever number, it overpressurizes the pipe. When something overpressurizes, what happens? It either will burst or leak, depending on the commodity going into it. These types of attacks are called living off the land techniques. There are already systems which are managing these pipelines for those technicians who are sending oil in through the pipe or gas through the pipe. What if, instead of a good human being or a technician, a bad person has access to that HMI or a SCADA system, they send a command, increase the pressure up to a certain point, and now you have gas flowing at a certain pressure, and it could actually explode. I highly recommend to you, as Rajat said, and in fact, I watched that movie as well called the Deep Sea Horizon. Deep Sea Horizon. It's a movie about safety. It's a movie about how things can go wrong. And while on your screen, they still look good, but in the back end, you're actually oil gushing out of your rigs and creating a havoc on the systems. So, and these are realities. I can go on and on. They have happened in the Ukraine-Russian war. Electricity has gone out for 300,000 people. Malware has gone in and wiped out the systems. The Old Smart Florida incident, the hackers had access to the chlorine, which they could up in the HMI, in the system for the water treatment. Imagine, these are systems which you and I depend on. I turned that pipe on of the city of Edmonton and hope that I'm not going to die drinking that water, right? So it has to be very, very important for us to understand what can go wrong with some of these systems with a small tweak of these configurations.
The next one is a common, OT, protocol we will study, which is Modbus, which is still one of the widely used protocol in the OT systems. So what we will be doing is that we will be doing a packet capture of a Modbus command and writing a register. So these industrial protocol traffic, again, the same thing. I may be technically qualified to understand all that thing. Many of the IT-savvy people or hackers may not be, but using simple tools or the tools which are available to a cybersecurity guy or any hacker or anybody else, free tools, no money, you can actually analyze some of those systems and you can create that. So my objective of the next presentation is that to study an industrial protocol, how the commands and response to those commands comes, and how using a simple Wireshark you can actually have the visibility of what's going on inside. So here we go. So I have a simple Modbus slave running here. This is a simulation. So exactly what we see there, on my unrelated prop. One of the device could be a Modbus slave, and the PLC could be actually integrating that controller and running commands over it. So I have a slave here, and then I have a master.
So just to give you an idea, okay? So while he does the demo, what actually is happening is on this dashboard, if you know, the actual actuator or whatever the operating system is, or the actual machine is at level 0. It is being handled by a PLC, a programmable logical controller. You can all Google it later on. And then an HMI, which is going to control the PLC, which will ultimately control the physical process which is going to run. So the Modbus protocol runs through the HMI, through the PLC, out into the actuator and runs the physics of it. But this protocol in itself natively is insecure. There's no encryption. This protocol whenever it was created mostly to run the systems, not from a cybersecurity perspective in mind. So that's what Rajat is showing. He'll show some master-slave configuration and how we can manipulate the numbers, but it could be very easily used, and it is very heavily used protocol in the OT space these days even. Just like TCP/IP, if you all know, TCP/IP was not meant to be secure. It was created to be a protocol to run the World Wide Web. But then lo and behold, we are at the stage where now people encrypt and do a lot of things over it, right?
So to run this little experiment, I have a Wireshark running on the background, and right now I have figured this Wireshark as a Modbus only. So right now there is no traffic; it's just total 0. And what I'm gonna do is that and we have a slave here. So we see this number 0. At 0 we have 21, we have 43, 65, and so on and so on. Let me just clear this out for us. What I'm gonna do is that I'm going to read from this slave ID, which I know that this slave ID is 1. I'm going to read 10 registers. So read 0 from 9, and I run it, and it's going to give me a value here. It is a master system, but look what the Wireshark did again. So the Wireshark immediately captured that I'm trying to run a Modbus read command, read holding register, and I'm going to read 10 registers. And then I go here, this is the response. I send a query, I get a response, and the response tells me, voila, all the numbers. So now I'm into a OT protocol, and I'm able to see the command and responses.
You're basically reading the registers of the PLC from that command. And that's the important part. Don't worry about the technical details. One thing you can get from this is Wireshark is the Swiss Army knife of network security.
Right.
So you can get Wireshark and run it, and it'll have OT protocols also figured out.
Right. And the thing is that, with a little bit of intelligence, and you can capture 90 days of data out from the Wireshark, and you can use tools to analyze that data. You can actually find out its data. Like if you change one data, a second set of data is getting changed. Like we mentioned the pressure, right? There is a set point, the pressure is regulated, so there is a fixed number, and another number is just going a little above and beyond it. If you can find those two combinations, this number, if you change this number, the second number changes. And then you can manipulate the first number. So the idea behind this is, okay, I have a read, I can see what the values I can read, and then I have the master system, and I'm gonna write something here. So let's say I'm gonna just reverse the order. So I have 21 instead of 21, I will just keep 12, I have 43, so I will make it 34, and then I will make it 56, and 78, and 90. So I will clear this first, and then I am gonna write it. Like just go something. Okay, so right away I get the response from Wireshark. So the Wireshark is telling me somebody is trying to write these numbers 12, 3, 4, 6, 7, 89, 65. And it says that yes, the return is successfully confirmed. I have been able to write 4 registers. So by analyzing the read and writing things, we can actually have a 90 days record of these read and writes of Modbus, and we can actually figure out which changing what numbers, change what parameters. We don't have to be an engineer, we don't have to know everything about it, but with a little bit of intelligence, and hacking is all about trial and error. You do not know what's the result that you will expect. You just keep doing things, and something will trigger, right? So this is exactly the same thing. Without knowing any technical information of a chemical plant, you just play around with those protocols, see the read and write request, and just make sense which number change, what are the number. And then next presentation is going to be by Prashant, and he is going to actually inject a malicious command through Metasploit, which is again an IT tool. It's not an OT tool, but likewise, somebody can analyze this thing and then go with the IT tool, and he can actually affect an OT system.
Can you show me the presentation?
Yes.
By the way, I just got a 15-minute timer, so I'll try my best. There were 4 simulations, but I'll see if I could at least pull one or two on it to see, give you an idea of how things would work.
Maybe just
Yeah, we'll go with the architecture. So part of the simulation is, if you give me that board again.
Yeah, sure.
So this particular simulation, if I'm not able to finish it, you can again take me offline. There is a GitHub project called Fortifid, GRFICS version 2. It is graphical realism for ICS version 2 by a company called Fortifid. They have a free GitHub version. These virtual simulations, these virtual machines are actually from that simulation. So you can go through their details and create it on your own, basically a laptop or a lab. So the architecture, which is what that simulation goes through, is you will have, there's a PLC, which is a virtual machine. There's a workstation, which is basically a normal computer, which can run commands or which can upload configuration files in a PLC. We all know a PLC is the brain of the process. If this is a physical process running the system, PLC is very important because it controls the whole logic around it. So it's a very critical system for OT, which can be compromised, okay? Then we have a simulation virtual machine. It's not in real life you get in OT space, but there is a simulation which I'll show you quickly. And then we have a pfSense firewall, which is a firewall which creating a network segmentation between our OT network, and then a network which is, in a nutshell, your HMI. We are going up till the HMI phase here. We're not going to the SCADA, which is a different topic altogether, okay? So human-machine interface, there's a virtual machine for that, and there's Kali Linux. Kali Linux is offensive cybersecurity. There's a virtual machine you can run to create havoc on the system. So this is just the architecture of the simulation. Just wanted to give you a context before we go into the simulation, and I'll see how much I can pull through it. But if you can move towards the... So what you're seeing on the screen here is the, by the way, let me give you a quick spiel on the virtual machines which are running. There is a PLC virtual machine. There's a Kali Linux I told you about. There's a SCADA BR, which is basically an HMI. And then there is a chemical plant simulation, which is another virtual machine, and pfSense, which is a firewall on VirtualBox. So you can run this on VirtualBox, create your own network configurations, and look around it. I'm not running the workstation machine right now because the simulation does not call for one. So that's the kind of the virtual machines running on the VirtualBox there. And then what you see here is, since I've already have them running, this is the HMI, what you see on the SCADA BR system. So this is a boiler. We are talking about a chemical plant. So a boiler which has inputs for chemical and then outputs coming out of it, okay? And then you have certain kilomole per hour going in, certain pressure and level in there. I'm not a chemical expert by any means. I just look at this and like, yay, it's working fine, right? But it is green and it is working okay. So this is a simulation of an HMI, which is connected to a PLC in real time through those virtual machines I talked about. There's also a PLC. This PLC, which we were talking about, has a web interface. That web interface is what's shown there. You can actually upload a configuration file on the PLC to play with it and kind of create havoc around it. So just giving you an idea that this is an open PLC. This is another software from open source. You can get it from GitHub. It's packaged into Fortifid simulation platform, but you can run, you can stop, you can choose files to upload the PLC program and create havoc around it, okay? And here is the simulation of the plant. Again, actually, this is the one when it is already blown up. So this is from the previous simulation I had, and I had to reset the machine. I didn't have find time for it. But so when I kind of turned it on to them, like, oh, it's already blown up. Okay. But this is how it looks like in the end, just to give you an idea. You have the simulation going in. These were normal levels, normal pressures. When you create some of those parameters for hacking them, which I'll talk maybe in one of them, and you increase the pressure and come it to a point where it actually blows up and shows you. Or you can decrease the pressure and shut down the boiler as well. So that's what you can play with the pressure of the boiler based on the Modbus protocol I was talking about and how you can relay with that. Again, it's 10 minutes, so let me see what I can pull through. If I were to look at Kali Linux, आपने Kali Linux का वो दिखाएं? No, keep going. Yeah, I can. So yeah, so you have Kali Linux here, and if you remember the architecture, the Kali Linux was sitting at the HMI level. What I'm going to do is I'm going to ARP spoof. So what you had here this was the HMI, and the HMI has an IP address talking to a PLC, okay? I'm going to ARP spoof, Kali Linux is going to ARP spoof the HMI's IP address and send a Modbus command to try to manipulate it. Because HMI is actually sending the real commands, but I'm going to create hey, I am your HMI, I'm going to send you the command. Because Modbus is not source authentication. It doesn't look at that. If you send it the command through a man in the middle or through a Kali Linux, it will take it. So we'll do a quick, so we'll do a quick let me open the so if I do Wireshark at this point in time, it will show me what packets are going back and forth because my Kali Linux is sitting at the same level as the HMI. Just need to make sure I'm listening on the right port. Give me a second. So I'm listening on Ethernet 1, which is the Ethernet network sitting next to the HMI on the same network. What you see here are Modbus and TCP flows going back and forth at that particular network, okay? If I stop it, I don't want too many packets going here, and I will filter on Modbus. So you will see that my Modbus is going between source and destination of 90.5 and 95.2. I know my IP scheme from the HMI that my HMI was at a 90. Quick second. That my HMI was a 90.5. So this tells me this much, that 90.5 is my HMI because I know that. I did not know my PLC IP address, but I do know now that it is 95.2. Okay, so that's one thing I know from Wireshark's capture, that what are the flows of the traffic going on. Now I'm going to use Linux to actually mimic 90.5 and then send a command to it. Okay. So how do I do? There's an ARP spoof command in Linux. Those who have in Kali, those who have played with it would probably know it. It's easy to remember and to play with it, but let me open it up. So I ARP spoof, and I do, because I'm in the normal, so it won't allow me, I need to do, I already had it from the previous demo. So what I have started doing now is I'm ARP spoofing the HMI and forecasting that I'm the HMI of the system. With this ongoing, this is one attack. This is basically you are ARP spoofing the HMI, you got to know the PLC, now you can effectively act as an HMI and start sending commands. So that's one piece of the puzzle from a demo perspective. Then once you have that, okay, so that's one thing. I mean, I can ARP spoof and send commands to it. There is another attack which is more around the Metasploit. So let me show you a quick Metasploit one. How many of you know what Metasploit is? Okay, good. So I'll be using a Metasploit. Hopefully it opens up. Takes a lot of time. There is a Modbus. While it does that, it's got time like that. So can you just go to this screen from the? How much time you have? 5 minutes. Maybe I'll leave this simulation. I'll just walk you through the steps of it. Yeah, quickly. So I was supposed to use I did the first demo, Metasploit in MSF console. I'll search for Modbus. There is a Modbus client which you could use. Now that client, you can set the IP address of the PLC. You can set write coils at the data address 40. So you need to know some of the gimmicks of it. But then you set a number 1 and set data coils to 1, and then you run it. It'll start bringing the pressure down of the boiler to a point where it actually stops. So what you have done, you have used Kali Linux at an environment at the level of HMI, and then you created the conditions to actually stop the boiler. That's one example. Not everybody can put Kali Linux at that level. What can you do? If you have access to the HMI, you can play with do the same things. That's what's called living of the land techniques. Anyway, I'll stop there. There are other demos too, and we have a presentation which we can send it also after the fact if you're all interested in this. We'll open up for questions, floor for questions, any comments, things you may have learned or things you may not have learned. So please go ahead. Yes, Ramiz.
You mentioned about the Modbus group. Is there any secure alternative to Modbus?
There is. So now the versions of Modbus has gone into what's called Modbus TCP. There's also an encryption layer people put on Modbus. It's called Modbus Secure. So, I mean, the underlying layer protocol is still insecure, but they have put a data layer on top of it. Just like if you have IP is insecure, but IPsec is secure when you create VPN tunnels. So similarly, there are versions of Modbus which are secure now. The question is, do products have those, and will they be able to take them on is a different question, because vendors accordingly have to up their ante and their game to create those, to use secure versions.
So just from your experience in critical infrastructure and do vendors support Modbus TCP?
Many do. But again, I don't know everything about every oil and gas company, what they're doing. Usually there is a lot of challenge of using Modbus as an insecure protocol. There are other ones too. There's DNP3, there is Profibus, there is Infinibus, there is Fieldbus, there are others.
So one of the things is that most of the systems are actually highly air-gapped. So there is a legacy Modbus system that exists, and many of my peers, they don't like to use any Ethernet Modbus protocol. They go with a serial RS485 kind of protocol, which is kind of unhackable, which is 30, 40 years old protocol. And the only way you can hack it, of course it's hackable, but you have to physically present and have 2 wires connected to it and manipulate it locally right there. With the charges of this is very, very rare. So many of my peers, they don't like Ethernet. They just change their system to those very, very basic.
We are going to find that out after running Shriram queries today on it.
Sure.
Yes, so currently these days, there are new products which have come where firewall is built into the PLC. So you could use the firewall capabilities in the PLC, or you could also use firewall at those lower levels of level 0 to level 1 to segment the network and make them, like I use pfSense, if you have seen. pfSense was segmenting the Kali Linux and the HMI from the PLC. So yes, you could segment those networks. You have to be very careful though, because these systems are, they have to keep running. If firewall impedes in real-time operations of a PLC or of an actuator or what the case may be, it can lead to downstream impacts of operations running. So we have to be very careful, but it is possible.
Yeah, one of the other techniques, some of my PhD did is that, if there is a 1 HMI or 2 HMI page, just reduce the subnet to the smallest ever possible number. Of course, it is not very flexible, but by doing that, reducing the subnet to a very, very small number, you cannot just insert another host into it who can inject. So there are many different techniques out there. Studying a little bit of OT provide that exposure, how we can protect these kind of systems. But again, it's more of an education. So the more you know about the system, the more protection you can build in.
Okay, we have to be honest of time to be, it is 20:15, I have another panel to go to. So, but please hit up both of us offline if you want to learn more about it. Thank you very much for coming. Really appreciate you taking your time.